Hello everyone, my name is Arpita and today I will be presenting my major project titled Sales Prediction Using Multiple Linear Regression. The objective of this project is to predict sales based on the amount spent on advertising through different media channels, namely TV, radio and newspaper. By building a multiple linear regression model, we can understand how each advertising channel affects sales and identify which channels contribute the most to increasing sales. Step 1 is importing the required libraries. In the first step, I imported all the necessary Python libraries required for the project. I imported Pandas and NumPy because they help in loading, cleaning and manipulating the dataset efficiently. Next, I imported Matplotlib and Seaborn, which are visualization libraries. These libraries help us create graphs that make it easier to understand the relationships between the variables. Finally, I imported different modules from Scikit-learn, including linear regression, train test split, and evaluation metrics such as RMSE and R² Score. These libraries are essential for building, training, and evaluating the machine learning model. Now, step 2 is loading and understanding the dataset. In this step, I loaded the advertising dataset into a Pandas data frame. The dataset contains 200 observations and 4 numerical columns: TV advertising expenditure, radio advertising expenditure, newspaper advertising expenditure, and sales, which is the target variable that we want to predict. I displayed the first few rows of the dataset using head function to understand its structure. Then I checked the dataset's shape, size and data types to make sure every column contains numerical values. I also checked for missing values using isna.sum function. Since there were no missing values, the dataset did not require any pre-processing or cleaning before model building. Understanding the dataset is an important step because it helps ensure the data is complete, consistent, and suitable for machine learning. Step 3 is Exploratory Data Analysis (EDA). After understanding the dataset, I performed exploratory data analysis. The purpose of EDA is to discover patterns, identify relationships between variables, and understand the overall distribution of the data before building the model. First, I created scatter plots to observe how each advertising channel relates to sales. From the scatter plots, it is clear that as TV and radio advertising expenditure increases, sales also tend to increase. However, the relationship between newspaper advertising and sales appears much weaker. Then I generated a pair plot which allows us to compare every variable with every other variable at the same time. This gives an overall view of the dataset and helps identify trends. Finally, I created a correlation heat map. The heat map shows the correlation coefficient between every pair of variables. A value closer to 1 indicates a stronger positive relationship, while a value closer to 0 indicates little or no relationship. From the heat map, we can clearly observe that TV has the strongest correlation with sales, followed by radio, whereas newspaper has the weakest correlation. These observations help us understand which variables are likely to be the most useful for prediction. Step 4 is building the multiple linear regression model. In this step, I built the multiple linear regression model. I selected TV, radio and newspaper as independent variables and sales as the dependent variable. The dataset was divided into training and testing data using train test split method. The model was trained using only the training data. After training, I displayed the model's intercept and regression coefficients. The intercept represents the predicted sales when the advertising expenditure is 0. The regression coefficients indicate how much the predicted sales increase when the expenditure on one advertising channel increases by 1 unit while keeping the other variables constant. Positive coefficients indicate that increasing advertising expenditure generally increases sales. Now, step 5 is feature selection. After building the initial model, I performed feature selection. The purpose of feature selection is to determine whether every feature contributes meaningfully to prediction. I trained different regression models using different combinations of input variables. For example, one model only uses TV and radio, while another uses TV, radio, and newspaper. These models were compared using the R² score. If adding a feature does not significantly improve the R² score, it suggests that the feature contributes very little to the prediction. This helps simplify the model without reducing its accuracy. Now, step 6 is training and testing and model evaluation. After training the model, I evaluated its performance using the testing dataset. I calculated two important evaluation metrics. The first is root mean squared error, or RMSE. RMSE measures the average difference between the predicted sales and the actual sales. A lower RMSE indicates that the predictions are closer to the actual values. The second metric is R² score. The R² score tells us how much of the variation in the sales is explained by the regression model. An R² value closer to 1 indicates better prediction accuracy. Together, these two metrics help determine whether the model performs well on unseen data. Step 7. Model diagnostics. Next, I performed model diagnostics to evaluate the quality of the regression model. I created prediction and residual plots. The prediction plot compares the actual sales values with the predicted values. If the points lie close to the reference line, it indicates that the predictions are accurate. The residual plot displays the prediction errors. Ideally, the residuals should be randomly scattered around 0 without forming any specific pattern. A random distribution suggests that the assumption of linear regression are satisfied and that the model generalizes well. Step 8 is interaction effect. In the final step, I created a new feature by multiplying the TV and radio advertising expenditures. This interaction feature represents the combined effect of TV and radio advertising. Sometimes the impact of two advertising channels together can be greater than their individual effects. I trained another two regression models using this interaction feature and compared its performance with the previous models. If the evaluation metrics improve, it indicates that considering the interaction between variables help the model make more accurate predictions. In conclusion, this project successfully developed a multiple linear regression model for predicting sales using advertising expenditure. Exploratory data analysis showed that TV and radio advertising have much stronger influence on sales than newspaper advertising. The model achieved good prediction accuracy based on the R² score and RMSE. Feature selection and interaction analysis further improved the understanding of how different advertising channels contribute to sales. Overall, this project demonstrates how multiple linear regression can be applied to real-world business problems and can help organizations make data-driven marketing decisions. Thank you.